The King's Cross departure boards showed 9 minutes to the hour. On the relief road, the engine had already been coaled, watered, and wiped down. A single pair of driving wheels in 8 feet and 1 inch in diameter. No coupling rods, no bogie tender to mask the mechanics. Just that enormous wheel, turning in open air. The year was 1888. The train was an East Coast Express. The locomotive was one of Patrick Stirling's singles, Great Northern Railway number 775, and it was about to demonstrate something that no preserved steam locomotive, no replica, and no modern engineering facility has since been able to reproduce in totality. Not the speed, not the elegance, the material. What the Stirling single was made of, and the methods by which it was assembled, belong to a manufacturing tradition that the 20th century ended without replacing. The puddling furnace, the hot riveting gang, the hand-scraping of bearing surfaces by a fitter who worked by feel and by light, those technologies are gone. The locomotives they produced are not, but only just. This is what was lost and why it mattered. Before we continue, if this kind of railway history matters to you, consider subscribing to the channel. Every video here is built around the locomotives and railway systems that the standard histories overlooked, the machines that outperformed their celebrated counterparts, the engineering decisions that were ahead of their time, and the railway lines that shaped nations without receiving the recognition they deserved. If that is the kind of documentary worth watching to you, the subscribe button is how you tell us, and we want to hear from you. Did you work on the railways? As a driver, a fireman, a fitter, a signalman, a track engineer? Did a parent or grandparent spend their career on a railway that is no longer operating, on a locomotive class that is no longer preserved, or in a workshop that is no longer standing? Leave it in the comments. The people who actually operated these machines know things that do not appear in any published railway history. We want to hear from them. Now, back to the locomotive. Patrick Stirling built 53 of them between 1870 and 1895 at Doncaster Works. The wheel arrangement was 422. Outside cylinders, 18 inches bore by 28-inch stroke. Boiler pressure on the first series was 140 pounds per square inch. The later 1884 series carried 160 pounds per square inch. The driving wheel diameter was 8 feet and 1 inch. No coupling rods, no mechanical connection between that enormous single wheel and any other axle. The adhesion was the weight, and only the weight, of the locomotive pressing down on the rail. The frames were wrought iron plate, 1.5 inches thick. That specification matters. We will return to it. The GNR Stirling singles hauled 275-ton expresses at a sustained average of 50 miles per hour on the London to York main line. In August 1895, during the races to the north, number 775 covered the 82 miles from Grantham to York in 76 minutes. That is 64.7 miles per hour average, with a train behind it. 20 years earlier, Daniel Gooch had produced something comparable on the Great Western Railway's broad gauge. The Iron Duke class of 1847, 29 locomotives built at Swindon, wheel arrangement 422, 8-foot driving wheels, boiler pressure initially at 100 pounds per square inch, cylinders 18 by 24 inches. In 1852, the Iron Dukes hauled the Flying Dutchman, then the world's fastest scheduled express, at 53 miles per hour average over the 194 miles from Paddington to Exeter. Recorded top speed was 78.2 miles per hour. Both classes shared a construction philosophy that is now, in its fullest industrial sense, impossible. The frames of the Stirling single were made from wrought iron plate, not mild steel, not high-tensile steel. Wrought iron, a material produced by a process called puddling, patented by Henry Cort in 1784, which required a reverberatory furnace, molten pig iron, and a man with a long rod stirring the metal by hand until it ceased to be pig iron and became something else entirely. What it became had a fibrous structure. Slag inclusions, evenly distributed through the iron during the stirring process, gave the finished bar a grain that ran in one direction, like wood. That grain made wrought iron uniquely resistant to fatigue, cracking along its length. It was forgiving in ways that mild steel is not. The puddling process was physically destructive work. The man at the furnace door, the puddler, worked in intense heat, they stirring 400 to 500 weight of molten iron. As the carbon burned off, the metal stiffened. The puddler balled it up, pulled it from the furnace, and the shingling hammer beat out the slag. Each heat produced perhaps 40 pounds of finished bar. Commercial puddling in Britain had effectively ended by the mid-20th century. The last puddlers retired. The knowledge they carried, the feel of the metal through the rod, the moment when the ball was ready to pull, went with them. What is sold as wrought iron today is mild steel. It is not the same material. A Stirling single frame cannot be replicated in the material it was built from, because that material no longer exists at commercial scale. The second technology was the hot riveting gang. A Victorian locomotive boiler was assembled by riveting, not welding. The process required 4 men working as a coordinated unit. The heater boy, who held the rivet in a portable fire until it glowed white hot. The catcher, who received the thrown rivet in a cone of sheet metal. The holder-up, who pressed the bucking iron against one head, and the riveter, who drove the other head with a hammer. The rivet, while hot, was soft. It filled the hole completely. As it cooled, it contracted. That contraction pulled the 2 plates together with a clamping force that a static bolt can't replicate. The joint was in compression throughout its working life. The timing was everything. A rivet held too long went cold. Driven too soon, it did not contract correctly. Yet the skill lived in the hands and the eyes of the gang, not in any manual. There are no hot riveting gangs, not commercially, not in any working locomotive workshop. The National Railway Museum's replica Iron Duke, built in 1985 for the Great Western 150 celebrations, was assembled with techniques that approximate but do not replicate the original process. The replica's boiler certificate has expired. It cannot currently be steamed. The third technology was hand scraping. Every bearing surface on a Victorian express locomotive, the connecting rod brasses, the slide bars, the axle box keeps, was finished by a fitter with a hardened steel scraper, removing material measured in thousandths of an inch until the surface mated correctly. The fitter checked his work with an engineer's blue, Prussian blue, applied to a reference surface. I pressed against the scraped surface and read. The skill took years to acquire. The tacit knowledge, the angle, the pressure, the reading of the contact pattern cannot be transmitted by description. It was transmitted by demonstration from craftsman to apprentice, over decades. That chain of transmission is now broken in most of the trades that built Victorian locomotives. GNR number 1, the prototype Stirling single, was withdrawn from service in September 1907, having run 1,404,663 miles. It was preserved, which was unusual. Most of the class was not. The last Stirling single was retired in 1916. The GWR's broad gauge, and every Iron Duke that ran on it, was gone by May 1892. The gauge conversion completed in a single weekend of extraordinary logistical coordination by roughly 4,200 men working the length of the line. Lord of the Isles, the last Iron Duke withdrawn, was kept at Swindon. In January 1906, the GWR scrapped it because the space was needed. These were machines built from a material that no longer exists, by methods that no one alive today practiced, to tolerances verified by a sensory knowledge that passed out of the trade before the trade itself declined. We can admire them in museums. We can measure their surviving components. We can build replicas that look like them and move like them. But the specific conjunction of puddled wrought iron, hot riveted construction, and hand-scraped bearing surfaces, assembled by men who knew no other way to do the work, that conjunction is gone. What the engineering record shows is this: those machines ran at speeds and with reliabilities that the technology supposedly incapable of producing them had no difficulty sustaining across careers, measured in millions of miles. The lost technology worked. If this is the kind of railway history you want to keep watching, subscribe to the channel. There are more locomotives, more railway systems, and more engineering achievements still to document. And if you have a connection to what you just watched, a family member who drove this class, worked in the workshops that maintained it, or operated on the railway that deployed it, tell us in the comments. What did they drive? Which railway, which depot, which line? The people who operated these machines are not in the standard histories, but the engineering record depends on what they remember. We want to hear from them.